When the German Tiger I first appeared on the battlefields of 1942, it caused genuine alarm across the Allied armies. Reports from the Eastern Front spoke of a tank that could destroy Soviet armor at over a mile away, shrugging off return fire as if it were nothing. In the winter battles near Leningrad, Soviet T-34s and KW-1s found themselves helpless against this new machine. Its thick armor, up to 100 millimeters on the front, rendered their 76-millimeter guns ineffective. The fear that spread among Soviet crews was soon matched by curiosity among Allied intelligence officers. What exactly had Germany built? By early 1943, the Tiger had arrived in North Africa. Under the command of the newly formed Schwerer Panzerabteilung 501, it was intended to crush Allied armor and reinforce Axis positions in Tunisia. The Allied tankers who faced it quickly realized they were up against something entirely new. The M4 Sherman, the backbone of American and British armored forces, could not match the Tiger in direct combat. Its 75-millimeter gun was largely ineffective against the Tiger's frontal armor. Even the heaviest Allied anti-tank weapons of the period struggled to penetrate it, except at close range. The Tiger's main weapon, the 88mm KWK-36 gun, had originally been designed as an anti-aircraft cannon. In a tank mount, it was devastating. Allied crews learned quickly that to engage a Tiger meant risking destruction before even getting into effective range. Within months, stories circulated through Allied lines. Tales of a single Tiger halting entire tank columns, of shells bouncing off its hull, of near-mythic survivability. Some of these stories were exaggerated, others were true. In either case, the legend had begun. By early April 1943, as Axis forces retreated northward in Tunisia, the British 48th Royal Tank Regiment encountered several Tigers from the 504th Heavy Tank Battalion near Medjez El Bab. In one particular engagement, fate intervened. A Tiger, later identified as Tiger 131, was struck by a 6-pounder shell from a Churchill tank at close range. The shot jammed the turret ring and disabled the gun. Another shell hit the commander's cupola, forcing the German crew to abandon the vehicle. When British infantry reached the position, they were astonished to find the Tiger largely intact. Unlike so many destroyed examples, this one could be recovered. And it was. The capture of Tiger 131 was a breakthrough. For months, Allied intelligence had been trying to obtain a complete Tiger for examination. Until now, most encounters had ended with the tank destroyed or beyond recovery. British engineers from the Royal Electrical and Mechanical Engineers immediately secured the vehicle and began basic repairs. The Tiger was hauled from the battlefield under heavy guard and sent to workshops near Medjez El Bab, where it was stabilized and prepared for transport. By May 1943, Tiger 131 had been shipped to England. There, at the Bovington testing grounds in Dorset, it was thoroughly examined, the first time Allied engineers could analyze a working example of Germany's most feared tank. At the same time, American ordnance officers stationed in Britain were invited to participate in the evaluations. Though the British technically held possession of the captured vehicle, the U.S. Army Ordnance Department saw immense value in studying the Tiger systems and incorporating the lessons into their own designs. The engineers were not frontline soldiers. Many had spent their careers studying engines, transmissions, and metallurgy. Yet even they approached the Tiger with a mixture of fascination and respect. Here was a machine that had defied Allied firepower and dominated early tank battles. They knew they were about to dissect one of the most secretive and sophisticated machines in the German arsenal. The engineers began with external inspections. Their first observation: sheer scale. The Tiger weighed approximately 54 tons, far heavier than the Sherman's 30. Its tracks were nearly 27 inches wide, designed to spread weight over soft ground. Its armor, sloped less than Allied designs but far thicker, could withstand almost anything the Allies had at the time. To Allied eyes, the craftsmanship was impressive. The weld seams were precise, the components tightly fitted, and the general finish superior to most mass-produced tanks. But even at first glance, the engineers noted potential problems. The suspension, composed of multiple interleaved road wheels, would be extremely difficult to repair in the field. If mud or ice jammed the wheels, entire sections had to be dismantled. For Allied tank design, simplicity and speed were paramount. American Shermans and British Churchills could be repaired quickly, often in the field, with interchangeable parts. The Tiger, by contrast, was built like a luxury automobile, precise but temperamental. As one British engineer noted in his technical report, "It is a machine of great mechanical merit, but not one that could be maintained in the field without a highly trained staff and ample spare parts." The more the Allied team studied, the more they realized that Germany's design philosophy differed fundamentally from their own. The capture of Tiger 131 marked a turning point. For the first time, the Allies could look beyond battlefield myths and examine the truth in steel and oil. Over the following months, American and British teams would take apart the tank piece by piece, measuring, documenting, and testing every component. Their goal was not to copy the Tiger, it was to understand it, to learn what made it deadly and what made it vulnerable. Inside the German Tiger, one American ordnance officer wrote, "We found brilliance, but also a fatal flaw." When Tiger 131 arrived at the Bovington testing grounds in the summer of 1943, it represented a once-in-a-war opportunity. For the first time, the Allies possessed a fully functional example of Germany's most feared tank. It was the mechanical embodiment of Nazi ambition: thick armor, immense firepower, and complex engineering. The tank was carefully unloaded and brought into the workshop of the Fighting Vehicle Proving Establishment at Chobham and later to Bovington. The first task was straightforward: make it run. British engineers spent weeks replacing damaged parts and restoring the electrical and hydraulic systems. The gearbox was jammed, and several components in the turret traverse were misaligned, likely from the Churchill's disabling hit in Tunisia. Despite these issues, the recovery team was able to bring the engine back to life. A Maybach HL230, a 23-liter V12 petrol engine rated at 700 horsepower. The moment the engine first roared back to life, witnesses described it as both thrilling and unnerving. The same sound that had once signaled death on the battlefield now echoed in a British workshop. The British engineers began systematic documentation. Every measurement, armor thickness, weapon penetration, and component weight, was carefully recorded. American ordnance observers from the U.S. Army's European Theater of Operations joined the analysis, cross-referencing German data when possible. Initial impressions were almost universally the same. This was a formidable piece of engineering. The 88mm KWK 36 L56 gun, derived from the famous Flak 36 anti-aircraft cannon, demonstrated extraordinary accuracy. In controlled firing trials, it consistently hit targets beyond 1,000 yards, with precision unmatched by Allied guns of similar caliber. Its muzzle velocity exceeded 900 meters per second, and its penetration at 1,000 meters was enough to destroy any Allied tank from the front. The optical sights manufactured by Zeiss impressed engineers with their clarity and precision. The dual magnification allowed German gunners to identify and engage targets long before their opponents could even see them. Allied crews had often described how Tigers appeared to fire first in every engagement. Now, the reason was evident. The armor was another revelation. The frontal glacis measured 100 millimeters thick. The turret front, nearly the same. It was high-quality rolled homogeneous steel, properly heat-treated and of excellent hardness. Even concentrated fire from the British 6-pounder and American 75 millimeter could not penetrate it except at close range. Yet the engineers also noted something curious. The Tiger's armor was mostly flat, not sloped like that of the Soviet T-34 or the later Panther tank. It relied purely on thickness, not geometry, to deflect rounds. This made it immensely heavy, contributing to its 54-ton combat weight, nearly double that of a Sherman. Attention soon turned to the Tiger's suspension system, one of its most distinctive features. The German designers had opted for a torsion bar suspension with interleaved road wheels, giving the Tiger a remarkably smooth ride and stable gun platform. In trials, it could fire accurately while moving, something most Allied tanks could not yet do. But when the engineers examined how the system was built, admiration gave way to disbelief. Each wheel was mounted in a staggered pattern, overlapping in 3 layers. To access one damaged wheel, crews in the field would have to remove several others first. In muddy or icy terrain, the gaps between wheels could clog solid, freezing the tank in place. The design was brilliant in theory, but utterly impractical under real battlefield conditions. As testing continued, the engineers' reports became more cautious. The Maybach engine, though powerful, had to strain enormously to move 54 tons of steel. Fuel consumption was extreme, roughly 500 liters per 100 kilometers, or just under 2 miles per gallon. In the deserts of North Africa or the forests of Russia, such thirst for fuel was crippling. Transmission reliability was another concern. The Tiger's gearbox, a Maybach Olvar EG 4012-16, was advanced but delicate. Field reports from captured German documents confirmed that transmission failures were common. Even during the controlled British tests, engineers found overheating issues and gear malfunctions after extended runs. To maintain a Tiger required time, resources, and skill, luxuries the retreating German army increasingly lacked by 1944. Inside the turret, the layout was tight but efficient. German ergonomics were designed for trained, disciplined crews. The loader's space was limited, but the ammunition storage was orderly and easy to access. The gun's breech block was massive, but smooth in operation. The turret traverse system, powered hydraulically, allowed the gun to rotate 360 degrees in roughly a minute, faster than Allied electric systems at the time. However, the system relied on the main engine running. If the engine stalled, the turret had to be cranked manually, an exhausting task in combat. The engineers noted another key issue: the Tiger's ground pressure. Weighing over 50 tons, it struggled on soft or muddy terrain. Bridges often could not support it. Rail transport required specially widened flat cars and temporary removal of outer road wheels. In strategic terms, it was a tank designed for limited theaters, not fast-moving warfare. By late 1943, the Allied technical teams had compiled hundreds of pages of data and diagrams. The final assessment described the Tiger as a weapon of extremes, unmatched in power, armor, and engineering sophistication, but burdened by its own excesses. A U.S. Ordnance report summarized it succinctly: an outstanding example of German design and manufacture, but an uneconomical use of materials and manpower. British evaluators reached a similar conclusion, noting that while the Tiger excelled tactically, it was strategically inefficient. Each Tiger required roughly 300,000 man-hours to build, nearly 3 times the effort needed for a single Sherman. At the Aberdeen Proving Ground in the United States, where parts of damaged Tigers were also examined, American technicians compared the design philosophy directly. The Sherman was not as glamorous, thinner armor, smaller gun, but it could be built, maintained, and fielded in enormous numbers. Mechanics could swap an engine in hours. Spare parts were standardized. Production lines never stopped. The Tiger, by contrast, was a mechanical masterpiece trapped inside its own design perfectionism. This realization began to change the way Allied ordnance officers viewed the German war machine. What had once been seen as terrifying technological superiority now looked more like overengineering, a pursuit of perfection that ignored practicality. The moment of revelation came during prolonged mobility tests at Bovington. After several hours of continuous driving, the Tiger's gearbox overheated and failed. The tank ground to a halt. To the British engineers, the breakdown was not disappointing. It was instructive. It confirmed what frontline reports had hinted all along. The Tiger's strength came with fragility. One observer recorded in his diary, "It is not a tank built for war as we know it. It is a tank built for display, powerful, intimidating, but unsustainable." For the men who had fought against it, the discovery carried quiet vindication. The Tiger was no invincible monster. It was a brilliant but brittle creation, crippled by its own ambition. The engineer's work was far from over. Every component of Tiger 131, from its optics to its armor alloys, would be documented and tested. In the coming months, their findings would circulate through Allied command, influencing future tank designs and confirming a vital truth. Wars are not won by the most powerful machines, but by the most reliable ones. The Tiger remained a marvel, but one destined to fail under its own weight. "We found the beast," one U.S. ordnance officer concluded, and discovered it could barely move under the burden of its own genius. By late 1943, the British and American engineers had run Tiger 131 through every conceivable trial. What began as a curiosity, a captured trophy of war, had turned into one of the most important technical investigations of the Second World War. Inside the workshops at Bovington and Chobham, reports were stacking up, pages filled with measurements, metallurgical analyses, and performance data. The Tiger's secrets were now laid bare. But the deeper the engineers went, the clearer a paradox became. Germany's most feared tank was also its most self-defeating creation. Fuel consumption trials were conclusive. The Maybach HL230 burned almost 500 liters per 100 kilometers, giving the Tiger a practical range of less than 100 miles on roads, and far less across broken terrain. To keep a single Tiger operational in combat required constant fuel resupply, something the German logistics system could no longer provide by late 1943. Transmission endurance tests confirmed the other half of the problem: overheating, rapid wear, and eventual failure under sustained strain. During one mobility run, the gearbox seized after barely 2 hours of operation. The Tiger's own complexity was its undoing. It was a machine that demanded peacetime conditions in the midst of total war. Frontline intelligence quickly confirmed what the test showed. Reports from Tunisia and later Italy described Tigers abandoned intact. Victims not of enemy fire, but of failed transmissions and empty fuel tanks. Captured German crews corroborated it. In interrogation notes held by British intelligence, one driver described his tank as, quote, "a palace on tracks, until the moment it stopped moving." The Tiger's reputation had terrified Allied tankers for a year, but now the fear began to fade. The engineers' findings gave soldiers something they had lacked: perspective. The Tiger was formidable, yes, but not immortal. It could be outmaneuvered, outnumbered, and ultimately outlasted. At the Fighting Vehicle Proving Establishment, the conclusions circulated quickly through Allied design bureaus. The British were developing the Cromwell, and soon the Comet, tanks that emphasize speed and reliability over heavy armor. The Americans focused on refining the M4 Sherman while preparing the M26 Pershing, a heavy tank that balanced firepower with production practicality. No one sought to build a Tiger of the West. The lesson learned was the opposite: never trade reliability for perfection. In war, quantity and maintainability win campaigns, not engineering grandeur. As the engineers finished their reports, one realization stood out. The Tiger reflected the mindset of its creators. The German design culture prized mechanical excellence and precision to an obsessive degree. Every component was crafted with near watchmaker care, but that same perfectionism made it fragile in the chaos of war. The Allies, by contrast, embraced standardization and pragmatism. A Sherman engine could be swapped in a day. Spare parts were interchangeable across thousands of vehicles. The British engineers who had once looked at the Tiger with envy now viewed it with a kind of tragic admiration, a monument to brilliance misapplied. By the end of 1943, the final evaluation report of Tiger 131 was complete. It praised its power and accuracy, but condemned its inefficiency. Formidable in design, impractical in deployment, one line read. A weapon too advanced for the war it was built to fight. That report would circulate to Allied ordnance departments across the Atlantic, and its lessons would outlive the Tiger itself. The engineers had pulled back the curtain. Now came the real question. What would those lessons mean for the wars yet to come? When the engineers shut down Tiger 131's Maybach engine for the last time, few realized that they were closing a chapter in the history of armored warfare. The tank that had once symbolized German invincibility would soon teach its enemies, and the generations that followed, how not to build a weapon of war. The post-1944 Allied design philosophy directly reflected the Tiger's autopsy. The principle was clear: simplicity equals strength. British engineers prioritized sloped armor and mobility in the Comet, and later the Centurion, the first truly modern main battle tank. In the United States, the M26 Pershing and later the Patton series embodied the same balance: power without fragility, complexity without excess. Even the Soviets, who had faced the Tiger on the Eastern Front, refined their T-34/85 and later T-54, focusing on ruggedness, speed, and mass production. The Tiger's over-engineering had done more to guide Allied tank evolution than any battlefield encounter. After 1945, Tiger 131 was studied again, this time by post-war researchers seeking to understand how wartime technology shaped the coming era. Its lessons carried straight into Cold War doctrine: avoid excessive mechanical interdependence, prioritize maintenance access, balance armor, firepower, and mobility, never maximize one at the expense of the others. The modern main battle tank concept, epitomized by the Centurion, Leopard 1, and M60, was in part born from the Tiger's failure. Yet even as engineers absorbed those lessons, the Tiger's legend refused to die. Captured in Allied propaganda, wartime diaries, and later popular media, the Tiger became a symbol of raw German power. Films and books exaggerated its invincibility, feeding the myth of the unstoppable Nazi war machine. Ironically, that myth owed much to the very fear the engineers had dispelled in 1943. In truth, the Tiger fought in small numbers, fewer than 1,350 units ever produced, and most were lost not to enemy guns, but to breakdowns or abandonment. Still, for the men who had faced them, the memory of that 88mm gun and the sight of those massive tracks remained unforgettable. Tiger 131 itself went on to a second life. Preserved at Bovington, it became a central exhibit of the British Tank Museum and remains the only running Tiger 1 in the world. Its restoration in the early 2000s brought the machine back to life for a new generation. In 2014, it even appeared on screen in the film Fury, portraying a Tiger in combat for the first time since 1945. But standing before it today, one does not see a monster. One sees a relic of human obsession with perfection, frozen in steel. Every dent, weld, and patch of rust tells the same story the engineers discovered in 1943. Brilliance defeated by its own excess. From the engineer's viewpoint, Tiger 131's capture had given the Allies an edge far beyond intelligence value. It revealed something timeless about technology and war. Power means nothing if it cannot be sustained. Engineering genius means little if it cannot be maintained. The Allies had learned that victory lay not in perfect machines, but in machines that keep moving. And so, in a quiet English workshop, amid the smell of oil and iron, the myth of the Tiger was finally tamed, not by fire or shells, but by understanding. Today, Tiger 131 still starts, still moves, still roars, a ghost of a vanished empire. But its voice no longer intimidates. It educates. Its story, from the deserts of Tunisia to the test bays of Bovington, remains a reminder that even the mightiest weapons can betray their makers when perfection outweighs practicality. In that sense, the engineers who dissected Tiger 131 did more than capture a tank. They captured a truth, one that shaped every tank that came after. "We feared it," wrote one British officer, "until we understood it. Then it was just another machine. And that's when we knew we'd won." If this story interested you, subscribe and give it a like to help others discover real World War II history.